Okay, and there's just one more thing I will need to say. That is the units. The SI unit for energy is joule. That is the SI unit. However, in this class, you will see usually we use kilojoule. Kilojoule is equal to 10 to the third joule. Kilojoule is not SI. However, you will see this unit a lot in this class because for engineers, the unit joule is just way too small. So that's why we usually use kilojoule as engineers. Okay, so after reviewing what you learned before coming to this class, we're gonna expand your knowledge about work, broadening the understanding of work. Okay, so the first thing we need to say is about the sign convention and notations. So we do have positive work. We also have negative work. Work does have a sign. It can be plus, it can be minus. So what does each one mean? If the work is positive, that means your system generates work. If you have a negative work, that means your system consumes work. That's what it means. Can you think of one example where your system generates work? So for example, we can use the same example. Your engine. How does your engine work? Your engine burns the gas and then converts the heat into mechanical work so you can drive your car. So your engine actually generates work so you can drive your car. So that's one example. Another example is power plant. How does a power plant work? For example, you burn whatever fuel you use. For example, natural gas. You burn natural gas, you generate heat, and then what power plant will do is to convert this heat into electricity, which is also a format of work. So what the power plant does is to generate electricity, which is just work. Your power plant generates work, then this work must be positive. Can you think of one example for negative work where your system consumes work? One example I can think of right now is your AC. So for example, in summer, it's really hot. You turn the AC on. What do you have to give the AC in order for it to work? You have to give the AC electricity. So that means your AC consumes electricity, and electricity is also one format of work. So your AC consumes work. That's why this work must be negative. That's the first thing, the sign convention. We do have positive work and negative work. Okay, the next one is power. Power. Okay, what is power? The definition is really straightforward. In this class, we use W with a dot on top of it to indicate power. W dot for power. What is the definition of power? The definition is power is equal to work over time. That is the definition of power. And then what is the unit? We can find out the unit from the definition very easily. The unit for work is joules divided by time, which is seconds. So the unit for power is joules per second, or you can just call it watt. They are equivalent. Watt is the SI unit for power. Okay, let's continue. How do we calculate work? The equation we used before is force dot product displacement. That's the definition of work. Plug it in and then divide by time. Okay, now take a look. What is displacement over time? Displacement over time has a name. What is it? It is the definition of velocity. So you can find out the equation for power is force dot product velocity. Okay, and let's continue. From this original equation, can we rewrite W? Yes, we can rewrite W easily. Work can be rewritten to power multiplied by time. You just move time to the left-hand side. That's it. Okay, so this equation is true to an extent. For example, if I tell you the power of my system is 10 watts, it's a constant, and I want you to find out work, how do you do that? You just plug in W dot equal to 10 watts back into this equation and then multiply by time. Then you can easily find work. However, what if my W dot, the power, is not a constant? If it is not constant, there's no way you can plug in W dot as a number. So there's no way this equation will work. So how do we need to rewrite this equation? It's very straightforward. What you need to do is just to rewrite this multiplication between W dot and T into integration. Change multiplication to integration. Integral W dot dt from T1 to T2. This is the more general solution. If W dot is not constant, you should use the second one. Okay, so let's do one example quickly. Case number 1, W dot is given, power is given, is 10 watts, it's constant. We want you to find the work W over 20 seconds. Case number 2, given power W dot is equal to 6T watts. So be careful here. This time the power W dot is no longer a constant, but 6 times T, which is a function of time, is no longer a constant. And then find work again, still over 20 seconds. Okay, so let's do part 1. Part 1 is very straightforward. Because W dot is constant, I can directly use this equation. W is equal to W dot multiplied by time. We plug in W dot, which is 10 watts, SI unit, multiplied by time, which is 20 seconds. Solution is 200. Because I used SI unit for every parameter when I plug in this equation, my solution must also have an SI unit. What is the SI unit for work? It's joule. Okay, so that's number 1, very easy. And then part 2. Part 2, how do we find work? Can we still use the same equation? No, because this time W dot power is no longer a constant. It's a function of t, time. So we have to use the integration from T1 to T2, W dot dt. So now plugging W dot is 6t multiplied by dt. Lower limit, we start from 0 second. Upper limit, 20 seconds. So our solution is integral 6t. What is that? 3t squared from 0 to 20. All right, so again, our solution will be 1200. And what is the unit? Because we used SI unit for everything in our calculation. So our solution must also have a SI unit, which is joule. Okay, so that's one very simple example for calculating work.